Hey guys, welcome to Horizon, and my name is Sephus. You must have seen me online on the Discord chats. Um, Definitely know some people out there who are in the community and contributing to us, helping us in the community. And So basically, today I want to discuss the software and what we are accomplishing at Horizon, and what are the limitations, the scope, the state of the project, and the overall concept of Horizon, basically. So, and there's a lot to discuss about Horizon. There are too many things. So I'm going to take it slow and I'm going to make it easy for people to understand. So let's start with understanding what is Horizon first of all. So Horizon is a very modern and very powerful Ragnarok Online emulator. Um, that being said, um, basically we want to emulate the Ragnarok Online game, and we are using the client of Ragnarok Online, and all the commands that are sent from the client are managed and processed on the server. So to process those commands and analyze the scope of the usage of the entire server side, the back end of the project, of the game, we want to uh, create concepts that will make the server side engine more powerful and more efficient, scalable and maintainable as well. So currently, my plans are that, based on the previous generation of emulators, based on Rathena and eAthena, we're going to use some of their concepts. Basically, conceptually, there's a lot of room to develop and innovate to create a modern and new MMO emulator, basically. Using that knowledge that they've put into the software of eAthena, we will take away the mathematical concepts. So we're taking the math from that emulator, utilizing all your hardware that we can, and making sure that the emulation of the server is very efficient, very powerful. So basically, what I want to do with Horizon is that use the um, you know as I've stated before in some of my posts, I want to take multi-threading as a new concept, as a possibility that will change the emulation of Ragnarok Online. I've spent a lot of time, a lot of years, analyzing the code of eAthena, and I think that the software can be better. That the initial concept of the software was good, and that it worked, and a lot of people use the software, but I don't think it's enough, because the I think Ragnarok Online is an amazing game, and people will play it for the next 20 years, 30 years, and then and that the software can be made better, can be used with more processing power, can be applied to the software. You can get more out of multi-threading, which we don't use in that software. We can get more out of memory management, and takes things more carefully in planning and in designing a new software. uh, we can use the concepts and the knowledge that was put into EFNA, and we can take that knowledge, which is basically in software design. People didn't care about the code that they put into the software, whether it went well with the other components on uh, which were directly integrated with the changes that were made in the software, whether the um, code was um, designed in such a way that it helped the overall concept of the software. I don't think they paid much attention to that because they just wanted to get the functionality running, and they wanted to get the software working and get the servers up and running, and players could enjoy the pirated software. So I think that um, down the line, we can utilize a new software. We can work on what we created before and take the knowledge and the concepts from that software and spend some time on the design of what we have made and create a better software from the start, because EFNA wasn't made for a multi-threaded environment. I think it is important to utilize most of the hardware of your setup of your system, uh, and I think that new software should be compliant with the hardware. And even though there's a lot of testing that goes on in ETHNA, there's a lot of continuous integration and development that happens when new releases are pushed. I think that EFNA did a great job. All the developers were amazing at what they did, but I think that it can be made better and it can be done amazingly for Horizon. So that is why I created Horizon. That is why I took things forward, um, you know, in development and in the design of the product of the software. Um, I think Horizon is one of the more challenging softwares compared to its previous generation, which is Ethena. I think that because of Ethena, a lot of players are already used to programming and coding in Ethena, and the environment of the system, of the product of Ethena, and they are very used to and very comfortable coding scripts as well in Ethena. So I'm taking all of the concepts that went into creating the software, the previous generation of the software, and I'm basically um, transforming it into a better new generation of work. Um, so my idea is that uh, the design of the product from the beginning of the software can be um, used to maintain the longevity and the sustainability of the software towards, say, in the next 30 years we wouldn't have to refer to a redesign of the software because we've already considered it in the start, and this hadn't been done with the previous generation of emulators. So nobody had considered the overall design at the beginning, thinking that we could use multi-threading software, multi-threading capabilities towards in the next 10 years, the next 20 years of using the software. They did not consider the way that modules were designed, the way that the components were designed. They just created components and added them together, and over time, over the span of 10 years, things just worked out. I mean, changes were made as many as possible, and people contributed, and I don't think too much work was done on the core concepts of the server. I think once it was created, people just used the product without thinking much about it. So Horizon is one of those emulators where everything is thought out from the start. Everything is planned and projected. Everything is architected from the start, from the beginning, and we are doing work of years worth of work in planning and designing of the software. So let's take a look at the project structure to begin with, and then move on to the other concepts and the system architecture of the software. So um, basically, the project structure begins with we have three artifacts that we create in this software project. First is the authentication of the server. Second is the character selecting server, and the third is the zone server, which manages the game basically. So a player logs in from the authentication server. He gets authority to transfer on to the character server and select his character, and then transfer on to the zone server, where the player can play his character basically in the world of Ragnarok Online. So what I have worked on in the last 5 6 years is that I think 7 years. So I is that um, the three artifacts that we have to share as much code as possible. So utilizing the main components of running a server, um, the server components will be shared amongst the three artifacts, and and in what they differ, in what the servers differ, the code will be extended on from that um, section, that frame of the code base. So um, with um, with the three artifacts, we have first um I've thought of creating a mainframe in each of the artifacts. So the mainframe is what we have today. We didn't have this 3 years ago. We did not have the mainframe. We just had basic components that were created and that went into the server design. We just It was only recently that we added the mainframe to the server. So basically, what the mainframe is that it's the heart of the server. It's the runtime mainframe, the procedures that will define the server's work, and during its lifetime, basically all the work that happens is inside the mainframe. So we have um, sub processes within the mainframe, um, and these processes are basically the management of the work, the components that are required to handle the work of the mainframe of the server. Basically, things like the database, the command line, the network process, all these different components come together and create the basic structure of the mainframe, and carry out processes and the functionalities that will be um, used and created within the mainframe. So The mainframe functionalities, I refer to them as the mainframe runtime. So the runtime functionalities are things like basically things that are the business logic of the server. So business logic would be things like creating a player, logging the player into the server, making the player log into the game world, the game logic layer, the basically the Ragnarok online world of the server, and logging the player out and things like that. Basically, utilizing the network commands that we get from the client to create the essential logic that will go on within the mainframe. Other than network commands, we have internal commands that the server will utilize, the mainframe will utilize to handle its own procedures. So things such as script commands and script functionalities that require the use of a database, that require the use of the command line maybe, and things like uh, the use of the network, the use of the game logic layer. These will be put inside the mainframe. Similarly, if the game logic layer would want to use parts of the script logic, this would also be part of the mainframe business logic runtime functionality. So basically, adding to that, we have three mainframes because we have three artifacts. So each server has its own mainframe, and in addition to the database, the command line, the network process, we have the persistence process in the zone mainframe. So in extension to the commonalities between the three servers, we have the extension of the zone mainframe server, which carries on and carries out three more processes: the persistence process, the game logic process, and the scripting process. And this belongs to the zone runtime. And basically, all these processes will be interacting to create business logic within the runtime, and modularity will be easier to understand and take place and utilize those components of the server, and be easy to use as well for developers, be easy to understand for us, and create a better environment to code in, create a better working software um, at the end of it, basically. And so, what I'm trying to explain now is the project structure. So, as you can see in the small box here, in the small box below my webcam um, video, you can see the project structure. So all the files pertaining to each of the processes, each of the zone mainframe uh, um, logic, uh, each of the sub processes are listed in the picture. All the files related to those processes are listed, and the files that not mentioned here probably have some a lesser use in the project. So these are the core files that go into creating Horizon, and it's been over, I think, 7 years that we've taken um, the the um, we've taken the you know the code to create the project. So it's been a long time, and there are lots of different pieces of work that have gone into into the code base. So I think it's a very important phase of the project right now to sit and design each of the components, each all the fundamental aspects of the program, basically. Um, so there are a few things that we can discuss now. It's also we have uh, the first is multi-threading. and how the system architecture um, um, is the mainframe communicates with all the different components of the project. Uh, the different components are uh, starting with console thread, the network layer thread, the scripting engine, the game logic, and the persistence thread. Uh, and this is the zone mainframe. So for the zone mainframe, we have 5 or 6 um, subcomponents. And since we are in an asynchronous environment, all of these communicate with each other and create the business logic within the mainframe. So the mainframe creates you has contains the business logic and um, makes it possible for all of these components to create what we need in Horizon, basically. So along with the database component as well. So utilizing all these components, uh, we get the entire runtime functionality of Horizon and the scope and the capabilities of Horizon. Without this, we would be lacking in Horizon's functionality, and we wouldn't know exactly uh, you know, how much how much work is left out, how much work is not going on, not happening in Horizon, um, as opposed to ETHNA servers. We did we there were it's a procedural based programming language that they use, and a lot of the functions, and there are basically only functions in that project, and we don't have classes, we have functions. So because of the functions, we get lost in a lot of code. There are 14,000 lines of code in each file. So because of the functions, and we don't know like the scope, the work of the functions, we don't know the scope of the function, we don't know the business logic, the logic behind several concepts that go behind creating the game environment, creating the code base. We don't know so many things because even though we read the code, we don't know what it's doing. We don't know um, you know what its scope is, what the variety, the limitations of the logic is, the logical procedures, the limitations of them. We don't know what could happen in that code base because um, not a lot of it is documented as well. So um, um, there's a lot of work that can be done basically to change that, and to keep a track of what goes on with your code. And if you design it from the beginning, we wouldn't have such problems that we deal with later because we hadn't taken it into account during the design phase of the project. We're gonna face issues with things like that in the forthcomings of the um, project. So um, for now, we are fully identifying the scope uh, and the capabilities and the limitations of Horizon, and we are utilizing every concept that we know, every aspect of programming to be taken into account when we create Horizon. And in this design phase, there's a lot of work on the um, project structure. So all the work that will happen later in the coming years, that are 10 or 20 years from now, is being done beforehand and is being done in the start of the project. So we know exactly how Horizon will run, what it needs to function, and what are the limitations and the scope of that functionality. So, summarizing all that, we have a fully capable software that utilizes multi-threading at its core, and it's not just an ordinary use of multi-threading. It's a very powerful use of multi-threading because we've understood the design of what multi-threading is, and we know how to use the concept of parallelism, of concurrency. We know exactly how to use that in Horizon, and we're getting the most out of the parallel processing that will take place within the software. And not only that, the parallel processing will help us create a, a server so powerful that um, it will be able to support tens of thousands of players at a single time. So a lot of processing will take place, and we are aiming to provide um, to a lot of uh, players, a lot of the user base, very large user base basically, um, and hopefully we won't have bugs and problems in the future, um, because of which the servers could crash or something like that. So we're taking care of all of that from the beginning and making sure that we don't face any issues as such in the later stages. So the language we're using is C++, and because it's a very powerful language, and it's more capable in providing um, mathematical um, um, you know foundation to software engineering and to the software that we are making. Basically, then it is then the capability of C. It's C++, I think, is more capable in managing things mathematically, and so it gives us great accuracy in what we're trying to understand and what we're trying to achieve with the software. So that's the basic system architecture. So the planning for the system architecture, and let me tell you in detail what goes on basically in the work of Horizon. The main thread is the thread that is started at the beginning of the software. So when the main thread starts, all the other threads go into an on a starting phase, in an initializing phase. So all the threads initialize and they begin to work, and the basically the server starts listening on the port of your login or authentication or character or zone, and it starts to work, it starts to function. It begins to accept packets from your client, and the server takes in packets from your client and processes them, and basically the several components come to life. All the processes happen. We can make things easy, but the more sophisticated that the work is of the server, I think the more segregation of principles, the more separation of concerns, of the concepts occur in the software. So that creates more space, more place for us to integrate smaller and tinier, services, tinier architectures, additions, expansions or extensions of the architecture, tinier places to expand on several logical um, um, processes, procedures. So the more we separate our concerns, separate the design of several different parts of the logic, the more we have a modularity, a more cohesion, um, you know, significantly improving the effectiveness of each component with the other components that go into the creation of the software, go into the working of the software, and basically they all work. The components work together seamlessly and more in a more sophisticated manner, in a more well thought out and sophisticated manner, and so we're using these concepts from several you know um, better software engineering practices that are being considered in creating the um, the software. And so uh, let's discuss how the system architecture works um, in more detail. So, you have the console thread, and the console thread works um, basically um, separate from the network layer. So, in separating the concerns of the console and the network layer, we create more room for the main thread to analyze and compare, have uh, basically create more room for more concepts between the console and network. There could be um, a layer that the console requires over the network, and utilize that. So uh, we want to implement um, whatever possible um, concept for Horizon for the um, complete logical um, completion, for the complete logical working of Horizon, uh, till its limitations in its in the scope of its working. We want to be able to um, add more things into Horizon. So there's always more place for logic and for processes um, in Horizon, as long as we separate the modules and separate the functionalities from the core functionalities of Horizon, and so we create more place for work for different processes and concepts, basically, that can be expanded or extended upon. They're basically creating extension points within the software to elaborate and extend the functionality of the software. So we have the network layer, we have the scripting layer, the scripting engine, which is an API basically for the LUA, the Lua language. So we're using Lua as the scripting language, and using Lua, we extend the functionalities of Horizon. And I mean, not only the functionalities of the game logic layer, because we could only extend the functionalities of the character, and we could only extend the functionalities of the map, um, related logic and functions. We could only extend monsters, but not only them, we can extend every other aspect, every other part of Horizon. So using Lua, we can extend console commands, we can extend the network layer, the persistence layer, you can extend the mainframe, and obviously we can also elaborate on the script engine itself. So Lua is very useful when it comes to being integrated with C and extending the language features. We could also use Python. Python is an interpreted language just like Lua, but it is used now today in data science and in artificial intelligence fields. So, what I have been planning for this project is that we stick to the dependencies that we are currently using for Horizon. We stick to um, um, Boost, which is an extremely powerful and extremely sophisticated, very well maintained, very well um, scrutinized, and functionally, you know, robust um, library. So we should use Boost. We should use um, the Python module from Boost. Where if we plan to extend the project and have AI enabled or integrated into Horizon. So what I'm thinking is, in the future, 20 years from now, 10 years from now, we want AI to be within Ragnarok Online. So we're gonna take uh, the neural networks and put them into the software and make things make train the models in the AI system, and we're going to use the data from Horizon, from uh, the functionalities of Horizon, basically, to create AI functions, create prediction algorithms, and things like that. So that will sophisticate um, the the game itself. Like Ragnarok Online will be super powerful, um, and a lot of work can be accomplished with this, and basically, so separation of the modules and yes, these segregation of the concerns create room for expanding upon more opportunities, such as what I mentioned, like AI and things like that. So we could have another layer, another AI logic layer that will keep training its models every time Horizon is at work, every time the map is working, every time there is more data created and um, um, uh, produced by the server, basically. So, that being said, I think we have discussed system architecture, and I think that um, this is the second level of the hierarchy of the diagrams that we've created. That will make things clear for you of how the project works and how the project is in its current state. So let's take a look at the GitHub page and see what is the current state of the project, of the issues, and what is the basic outline of the scope of what we are currently working on. So there are a lot of issues to begin with, because it's a new project. There are several different um, varieties of features that we need to add in the software. So by that I mean, um, in each of the servers we have different functionalities. So what I have gone and done is for example, listing of all the network commands that will be used within the server. So basically, in the server software, we don't only have network commands. We have more functionalities that go in the working of the server. But for now, we are just listing down the network commands, and the ones that are working, we've checkmarked them, and the ones that are not working, they remain unchecked. And basically, this is a list of the commands that will go into creating the runtime of the authentication of the server of the artifact. So, for example, this is the authentication server. So, um, in creating, say, for example, the accept login network command, we have the capability of creating the functionality of the business logic of the runtime, which will be accept login in the business logic. And so, because we know that there is a network command and the client will use this, we can create business logic based on this. So, we are currently in the stage of creating that kind of business logic and sophisticating that and expanding upon that and making more room for the complete possibilities of how Horizon will work in its business logic, basically. And these are the character network commands and the zone network commands that we have implemented and that work up to a certain point in um, in in functioning with the client, basically. We have the database system in which we store the items, the mobs, the skills, the skill tree in Lua, and we're using the same Lua the Lua language to store them in tables. We're not using a separate configuration, module or configuration file. We're using Lua itself because we already are using Lua for scripts. So it makes things more easier, most um, um, uh, concise, basically, to to understand. And war portals and fields and dungeons of war portals are stored in Lua. We have contributors who have helped with storing war portals and monster spawns, etc. So we have monster spawns, we have skill functionalities. So another thing I want to elaborate on is the skill functionality system of Horizon. So basically, my idea for creating skills in Horizon is that we can do it in Lua, because Lua is a beautiful and small and fast language. We can use the functionalities of Lua to create skills, and because we like to customize things so many times and in so many ways, Lua will provide that for us. So using Lua, we can create a more customizable code base, a more um, you know end game. More customizable gameplay because of Lua. So um, using these the skill functionalities basically can be created in scripting language itself. So instead of hard coding the functionalities, we will be taking the script and utilizing scripts to create skills. Um, so, for example, I think I have an example of a skill that I can share. Um, Let me check. Okay. Uh, so for example, let's take a look at the NV basic skill, the novice basic skill. So we go into the code of Lua where we already provided with the entity, the skill ID, and the skill level within the file. Every time the file executes, we will be provided with these three variables. So, and player will be nil at that point in time. So we want player to be initialized um, when um, when we determine what type the entity is. So uh, we go ahead and check if the skill is learned. If it is not learned, we produce a skill failure. If it is learned, we sit or stand, basically, depending on what the current posture of the player is. So if the player is standing, we sit. If the player is sitting, we stand. And it toggles the effect of the NV basic of the sit skill of the player. And it's a basic variety of how skills are implemented in Lua. Utilizing this concept, this uh, you know um, kind of a concept, basically a programmable programming concept. You can extend on what goes on, how things are created in the game, in the code base. So and it I don't and the effect on its performance is not too much. It's not going to be a very noticeable effect on the performance. It's going to be as contained, as limited as possible. So we're going to use Lua to create skills for characters and monsters, basically, because we want them to be as customizable as possible and easier to code. So scripters who used to program before using Athena code can now program skills, and that's a big bonus and a big upgrade from what they had the capability of creating before and what they have the create capability of creating now. So that's a very big change in the code base, basically, in the way things worked. Um, so this is the outline of the way things work in Horizon. Um, we have add command functionalities which were previously hard coded, and now they are moved to Lua, and it's easier to program. Add commands, which are GM commands, basically. Script commands, which were previously hard coded, are now moved entirely to Lua. We only have to interface the functions that we want to extend and componentialize from within C++ into Lua, and we get the functionalities into Lua, and we can just use them in all in features like these, like add command and script commands. So I think it's a very good way to extend the system, and things such as NPCs can utilize this, and we can have. So basically, Horizon is now divided. The team is divided into two main teams. One is the uh, the core development team of Horizon has been divided into two main teams. One is the core development team, and the second is the surface development team. So the surface engineers, what they will be doing is that they will be working on systems and processes such as guilds, parties, chat rooms, channel system, War of Imperium, PvP, faction, clan, storage, marriage, monster skills, skills, combat, damage, things like that. And the core functionalities, the core engineers will be working on things like fixing the implementations of MySQL, and using functionalities, changing functionalities of Boost, recreating or redesigning the system architecture. The unit system will be changeable because of that core functionality. Because of the core engineers, they can work on the unit system, and basically uh, the mainframe processes. So all these will be managed by the core engineers. So basically, anyone joining the team, the development team would have to decide whether they want to be, are they more concerned with surface engineering or core engineering. Because if you want to be the game side, the game feature developer, you would need to be the surface engineer. Or but if you want to be the core engineer, you would have to have knowledge of more in-depth knowledge of C++ and how things work with threads, how memory is managed, and things like that. So um, basically, I've created issues that are now going on now, significant to Horizon, which are now uh, basically the um, um, related to the concepts that are now being put into Horizon, um, and not related to the surface engine, because I'm a core engineer basically, and what I do is I create the core foundation for the software to be built. And surface engineering is a little more easier because the foundation is now built, and then you can just add on to the code base, the core functionalities, and you can just add on to them. It's similar to the kernel system, the kernel and the operating system basically. So the user land and the kernel system, the kernel, you know, the authorities in the kernel of the system. So um, these are the issues that are currently important at Horizon. Um, I think we've discussed everything from the start, from the beginning of the design phase of the project, to now the issues that are ongoing and that are being worked on at Horizon. And there can be more development, more in-depth um, discussions on Twitch, as I'm streaming right now. There can be more discussions, and in every detail and aspect of the project, and we can build from there. We can build on the project and on every concept uh, into a better working strategy, a better working function or component of the software. There are too many things to decide and too many things to work on, and I think we can take our time. We don't have to. We're not rushing into things. We are taking things as we understand them, as we learn them, as we program them, and I think overall we can achieve a better server than Athena. Uh, the reason for that is because there are certain concepts that are not very well integrated, very well developed in Athena, and we can take those concepts and create a better um, emulator for the future. Um, with that being said, I would like to end this introductory video on Horizon, and say that um, we are doing a good job on its current state and the way things have been. I think it's been a good amount of time that we have taken to create what we have now. Um, and from several years from now, I think we'll have an even better project. So um, uh, it's a good progress till now. Even though things are slow, it's a normal project, uh, normal at a normal pace of work for people. So with that, I would like to end this video and see you in the next one. Have a good day.